All right, you Maverick Renegades, bringing all the static. We're going to be doing static electricity with Coulomb's law. So let's work this out. We know that Coulomb's law is force equals K, which is the electrical constant, times the charge of one object times the charge of the second object, divided by the radius or the distance between them squared. Okay, so this is the equation we're going to be using. Let's go ahead and get right into it. What is the electric force? So we go here, force equals, this is what we're looking for, between two balloons, each having a charge of 6 times 10 to the negative 6 coulombs. Coulombs is the unit of charge. So we have, this is Q1 and Q2. Okay? And they are 0.25 meters apart, is the distance. Okay, so since we're looking for force, let's go ahead and just write the equation. K, Q1, Q2, times distance squared. Okay, we're going to go ahead and plug it in. Remember, in the calculator, I want to just put in the times 10. This is an E negative 6. That's how I want to write that, 6E negative 6. Okay, so let's see, what is my constant here? The K constant, you need to know this, the K constant is 9 times 10 to the 9th Newton meters squared Coulomb squared. You don't have to worry about this too much. Just know this is the K we're plugging in. 9 E9. It's nasty. 9E9 times my Q1 6 E negative 6 times my second charge, which is the same, 6 E negative 6, and then I'm going to divide the entire thing by my distance squared, which was 0.25 squared. Put this all in the calculator, try it out, and we end up with 5.18 newtons. Remember that force is measured in newtons. All right, cool. Let's move down. Let's try another one. If the force were 8 newtons, so right here I have my force, and the charge of the balloons were both this, so this is my Q1 and Q2. So I'm really not changing too much for the purpose of teaching you guys this. What is the distance? So this time we're looking for distance, right? So I write down the equation, force equals KQQ over D squared. Okay, so remember that trick. If I have a top and a bottom, what do? That's right, we switch them out, okay? So now my new equation looks like D squared equals KQQ over F now. And this isn't by itself. How do I get rid of a square? Square root. Okay, so that's my equation. So let's plug it in. Square root of my K constant, which was 9 E to the 9th, times both my charges, 6E negative 6 times 6E negative 6 again. Right to see that. And then divide by my force, which was 8. So we go ahead and do that. Let's put that in the calculator. 9E9 times 6E negative 6 times 6E negative 6 divided by 8. And then I'm going to go ahead and square root the answer. Okay. So the distance this time is a little bit shorter, right? Because the force went higher, so that means it must be a closer distance, right? So we had point, or further away, since they had a positive charge, they're going to push each other. Okay, 0.2 meters. Cool. So that's how we do that. Remember this like little thing right here, right? We have to do algebra. Okay, now these are more conceptual questions. These are going to ask like, what would happen if? So what would happen to the force? So force equals if the distance were doubled. So this is distance is times 2. Okay, so you remember when we do equations like this, if I don't change a variable, I just leave it as a 1. So since I'm changing the distance down here, everything else gets to stay as a 1. So I'm going to go 1 times 1 times 1 for the top. Down here, I'm doubling it, so put a 2 squared. So this comes out to 1 times 1 times 1. This is 1. 2 times 2, or 2 squared. You can put that in the calculator if you're not sure. It's just a fourth, so we'd have 25% of the force. Okay. What if the charge of the object were doubled? Charge of one object were doubled, so Q1 is times 2. So what would I do this time? Force equals K QQ over distance squared. So I'm just going to pick any one of these charges and plug a 2 in there, and the rest are going to stay as a 1. So 1 times 2 times 1 over my distance, 1 squared, so it's just going to be a 1. 1 times 2 is 2 over 1 squared, so it's just 1. So it would double. That's obvious, right? Good. All right. Good luck.